Hello everyone, welcome back to LMJ, and today I am back with another video which has the laws of motion PYQs from NSEP exam, and it has roughly 39 questions over a span of 21 years, and it is a very scoring question, and the questions asked are generally easy. And sorry for uploading the video so late. I was not able to record videos because I have started giving mentorship to students personally. So if you want good mentorship, you can reach out to me on Telegram. So let us begin with the first question. The first question says that a uniform sphere of weight W and radius 5 centimeter is being held by a string as shown in the figure. The tension in the string will be. Okay, so the situation is something like this. The tension will be acting in this direction on the string, and it will have, if this angle is theta, so this will be t cos theta and this will be t sin theta, and one normal from this wall will be also acting on the ball, and similarly the ball will exert a normal on the wall. And since we are taking the system as the ball, so normal will be in this direction and weight of the ball will be in this direction. So this theta is equal to this theta because they are alternate interior angles. So if we draw the triangle, this is 8 plus 5, 13. This is 5. So this will be 13 square minus 5 square, which is 12. So cos theta is 12 by 13. So weight will be, weight is given W. So we can find T in terms of weight, which is, so from here we will get 13 by 12 W, which is equal to option C. So moving on to question 2, it says that an object is suspended from a spring balance in a lift. The reading is 240 newtons when the lift is at rest. If the spring balance reading now changes to 220 newtons, then the lift is moving. Okay, so the lift is something like this and it is moving. We have to find out how it is moving. The reading was earlier. This is the spring balance, and this is, suppose this has mass m, so mg will be acting downwards and tension will be acting upwards. So tension is the reading which the spring balance shows, so mg must be equal to 240, right? And let us now see that when the spring balance will show 220 newtons. So option A says downwards with constant speed. So if the speed is constant, then there will be no change in the force equation because no acceleration is acting. So this cannot be the answer. B option says downward with decreasing speed. So this means that if the lift is moving downwards with decreasing speed, this means that the acceleration will be in upwards direction. Then only the downwards velocity will decrease, right? So mg is here and tension is here, but now we cannot write mg is equal to t because there is acceleration also. So it will be t minus mg is equal to ma, because acceleration A is acting, is the mass has acceleration A upwards, so tension will be mg plus A, which is greater than mg. So the reading will be more than 240 newtons because the reading is tension only. So this B option is wrong. C option says that it is moving downward with increasing speed. So the acceleration is downwards. So mg is acting downwards and tension is acting upwards. So mg minus t is equal to ma. So tension will be mg minus a, and since this is less than mg, so reading will be less than 240. So option C is correct, because 220 is less than 240. So option C is correct. So now moving on to question 3, it says a box weighing 6 kg is being pulled with an acceleration 0.5 meter over a rough surface with the help of a string as shown in the diagram. If the coefficient of kinetic friction involved is 0.1, then the tension in the string is. Okay, so this is the tension in the string. So this will be T cos 30, which is T root 3 by 2, and upwards there will be tension component T sin 30, which is T by 2, and normal will be acting upwards and mg will be downwards, and there is friction also, so friction will be in this direction. And since the block is moving, so kinetic friction will be acting, and kinetic friction is mu k multiplied by n always, right? So it will be 0.1 multiplied by Newton, matlab normal. So now we have T cos 30 minus 0.1 n is equal to mass of this multiplied by acceleration, right? Let me substitute the values. Mass is 6 kg and acceleration is 0.5, and in the y direction the equilibrium equation will be T by 2 plus n is equal to 6t mg, right? So from here we will get, if we multiply this with 0.1, we will get T by 20 plus 0.1 Newton is equal to 6, and then we can add these two equations to get T root 3 by 2 plus T by 20 is equal to 3 plus 6, which is 9. So 10 root 3 plus 1 times tension is equal to 180. So tension will be 180 divided by 10 root 3 plus 1, and this is approximately equal to 6.588. So the answer is option C, more than 6 Newton but less than 60 Newton. Moving on to question 4, it says an external horizontal force P acts on a block placed on a rough horizontal surface. The force of friction between them is F. The following graph best represents the relation between P and F correctly. So till the limiting friction, which is mu s multiplied by n, is reached, before that, before the external horizontal force P becomes equal to mu s by n, friction will be equal to P, right? Let me explain this. If this is a block of mass m and it is being pulled by a variable force P, so the friction must be equal to this P till the maximum value, because if friction is more than this P, then this mass will start moving backwards magically. That is not possible. So the friction must be equal to P till P becomes mu s n, and after it becomes mu s n, friction will be equal to mu k multiplied by n, and we know that mu k is less than mu s, so there will be a jump. So option B is correct, because till here F will be equal to P here this f will be equal to p, which will be equal to mu s multiplied by n, and here f will be equal to mu k multiplied by n. Hope this is clear. If this is not clear, you can ask in the comments or on my Telegram. So question 5 says that a block is placed on a rough plane whose inclination to horizontal theta can be varied. The angle of repose is 30 degrees. The graph that correctly indicates the variation of friction force F between the block and the plane with theta is. Okay, so angle of repose is the angle at which the block will start sliding down, right? Before that, the block will remain stationary. So if this is theta, when theta is less than the 30 degrees, so the block will have mg sine theta this way, and friction will be acting this way, and it will be equal to mg sine theta, because before the angle is less 30 degrees, the block will be at rest, and this is necessary condition for the block to be at rest. So till 30 degrees, mg sine theta will be the friction, and after that the friction will become mu k multiplied by n, right? Because after the angle of repose is reached, then the block will start sliding, and then kinetic friction will act, which is always equal to mu k n, and n is equal to mg cos theta, right? For the equilibrium in this direction perpendicular to the incline. So this will be mu k multiplied by mg cos theta. So at 0 degrees it will be 0, right? So this is wrong, because sine theta is 0 at 0 degrees, and at 90 degrees this will be 0, because cos theta is 0 at 90 degrees. So this is the correct answer. So moving on to the sixth question, we have a horizontal force of magnitude S is applied to a body of weight mg resting on a frictionless inclined plane to prevent it from sliding down. The plane makes an angle of phi with the horizontal. Then the normal reaction acting on the body satisfies the condition. So the body is on an inclined plane of angle phi, and a force is being applied in this direction to prevent it from sliding down, and mg sine theta will be acting in this direction, mg sine phi, mg cos phi will be in this direction, and since this is horizontal force, so this angle must be equal to phi, because this angle and this angle is equal. So this will be f cos phi, this will be f sine phi, and normal will be in this direction. So normal can be directly, we can see that normal is equal to mg cos phi plus f sine phi. So this is correct, and this is 6 marker question, so this is multiple correct. So now we need to find the relation. Here they have removed the f term, so this is obviously not correct, because f sine theta is here, and then we need to find f in terms of mg, so that we can see if this option is correct, because this can be correct if we change f in terms of mg. So mg sine phi is equal to f cos phi, so that means that f is equal to mg tan phi. So from here we will get that normal is equal to mg cos phi plus of mg tan phi sin phi, right? I have replaced f by mg tan phi, and sin phi is already there. So normal will become mg cos square phi plus sin square phi divided by cos phi, and we know that this is equal to 1, so it will become mg by cos phi. So option C is correct. And option D is saying that normal is the square root of mg square plus f square. So let us see if this is right. So we know that normal is acting in this direction and this is mg. So we know that this angle is equal to phi. So this angle is also equal to phi. So this will be n cos phi, and friction is acting here, and this will be n sin phi. So we can write that n cos phi is equal to mg and n sin phi is equal to friction, force, horizontal force. So if we square these and add these, so we will get n square sin cos square phi plus n square sin square phi is equal to mg square plus f square. And if we take n square common, then cos square plus sin square phi is 1. So option D is also correct, right? So moving on to question 7, it says that a particle is subjected to two equal forces along two different directions. If one of them is halved, the angle which resultant makes with other is also halved. So the angle between the forces is. So this is a nice question. So let us see. A particle is subjected to two equal forces along two different directions. So imagine this is the particle and one force is in this direction and one force is in this direction. And let us assume that the angle is phi. So we know that the resultant will be acting in this direction and it will be making phi by 2 angle and phi by 2 angle. This is true because if we draw it like this, then this is phi and this will be the summation, right? By triangle of addition, this will be the f resultant and this will be f sin phi and this will be f cos phi. So this entire length will be the addition of these two terms. And if this is alpha, then tan alpha will be f sin phi by f1 plus cos phi. And we know that this can be written as 2 sin square phi by 2, and this can be written as 2 cos phi by 2 sin phi by 2. So this will become f and f will get cancelled and this 2 and 2 will get cancelled, sin square will get cancelled. So tan alpha will become tan phi by 2. So alpha is phi by 2. Okay, and then it is saying that if one of them is halved, the angle which the resultant makes with the other is also halved. So if this force is halved, then the angle is still phi, right? But the resultant is making half angle of this angle with this force. So they are saying that this angle becomes phi by 4 and this angle becomes 3 phi by 4. So we will get two equations now. First, from this diagram, it will be tan phi by 2 is equal to f sin phi by f plus f cos phi, right? Because this is phi by 2 And if we see from this triangle, then it will be f sine phi by f plus f cos phi. And from this triangle, we will get tan 3 phi by 4 is equal to f sine phi divided by f plus f by 2 plus f sine cos phi, right? Because uh, of this triangle. Right, this is the triangle of addition. So from the two equations, we can write cross multiply this, and then we will get that tan phi by 2 multiplied by f cos phi plus f is equal to f by 2 plus f cos phi multiplied by tan 3 phi by 4, because both of them are equal to f sine phi, right? So from here we can get that if we focus on these two relations, so we will get tan phi by 2 cos phi plus 1 is equal to half plus cos phi tan 3 phi by 4. Now this will match only for option D if you check one by one. Then if you put 120 degrees, then it will be tan 60 multiplied by cos 120 degrees plus 1. This will be half minus half, because cos 120 is minus half, and this will be tan of 90. Since this is infinity and this is 0, so you can say that if you take this infinity in denominator, then this LHS will also be equal to 0. So option D is correct. Now question 8 says that a given block takes n times as much time to slide down a 45 degrees rough incline as it takes to slide down a perfectly smooth 45 degrees incline. The coefficient of friction between the object and the incline is. Okay, so if this is perfectly smooth and this has mass m, so we can write that mg sine theta is equal to mass into acceleration. So acceleration will be g sine theta, and in the case when it is rough, we can write that mg sine theta minus mu mg cos theta is equal to mass into acceleration. So acceleration will be get as here acceleration was g by root 2, here it will be g by root 2 minus mu g root 2, which is equal to g by root 2 1 minus mu, right? And we are given that the time taken is n times as much time to than this acceleration, right? So the distance is same s, right? So s is equal to ut plus half at square will give us and we are given that this time T rough is n times of T smooth. So from here we will get T smooth is equal to and T rough is equal to so putting here we need to find mu, right? So I am squaring these. So if I cross multiply, I will get so this is option A. Moving on to question 9, we have a block of mass m is placed on a smooth horizontal surface. A force making an angle theta with the horizontal starts acting on the block. The magnitude of the force is constant, but its direction with the horizontal changes as theta is equal to a plus bs, where a and b are constant and s is the distance covered by the block. If the magnitude of force is 2 mb, find the velocity of the block as a function of the angle theta. This is a 12 marker question and this is a good question. So a block of mass m is on a smooth horizontal surface and the force is making an angle theta with the horizontal, and theta is varying as a plus bs, where s is the distance. So we will get that f sine theta plus n is equal to mg and f cos theta is equal to ma, which is equal to mv dv by ds. So from here I can get the velocity. Theta I am substituting because theta is variable, and the uh, variable in the terms of which we will be integrating is s. So the variable here also should be in terms of s, right? We cannot write theta here because the d, after d we have s. So at 0, this velocity was also 0 because the block is starting from rest. And at any displacement s, I am assuming the velocity to be v. So from here I will get sine a plus bs, and limits are 0 to s, and here I will get v square by 2. So f by mb sine a plus bs minus sine a is equal to v square by 2. And we know that the magnitude of force was given as 2 mb, so I can write this as 2 mb minus sine a. So mb will get cancelled and velocity will be root of 4 multiplied by sine a plus bs is theta only at any particular instant, and minus sine a, right? So this is the answer for this question. This is a nice question. Okay, so moving on to question 10, it says that two pulley arrangements A and B are as shown in the figure. Neglect the masses of the ropes and pulleys and the friction at the axle of the pulleys. The ratio of the acceleration of mass m in the arrangement A to that in the arrangement B is. Okay, so in option A, it will be something like this, that 2 mg is acting here, T is acting here T, and here mg, and acceleration in this direction. So 2 mg minus T is equal to 2 ma, and T minus mg is equal to ma. So mg is equal to 3 ma, and acceleration is equal to g by 3. And in this case, the tensile will be 2 mg only, right? Because if this force is 2 mg and this string is massless, so at every point the forces, if I take a small section, 2 mg is acting here, and so the tension upward should be equal to 2 mg, because if the force is not equal to 0, so mass is 0, so if I divide this by, if this is 0, then acceleration will become infinite, so force should also be equal to 0. So here also, if I take small elements all the way along, I will finally get that this is also equal to 2 mg, and 2 mg minus mg is equal to ma. I will get a is equal to g. So the answer will be 1:3. Moving on to question 11, it says that two masses small m and capital M are attached to the strings as shown in the figure. In equilibrium, tan theta is equal to. Okay, so let us begin from this side. If this is tension and this is some T dash, then this will be T by root 2 and this will be T dash by root 2. So from here we will get that T by root 2 is equal to T dash by root 2 for equilibrium. The force should be 0 in this direction. So this will give us that T is equal to T dash. So in this direction I will get that 2T by root 2, which is root 2T. So root 2T is equal to mg. So T is equal to mg by root 2. And on this thread also, the same tension will be acting, which is mg by root 2, right? Because T is equal to T dash. So drawing this point here, this will be T dash cos theta, this will be T dash sin theta, and this is angle alpha, so this will be mg by root 2 cos alpha, this will be mg by root 2 sin alpha, and the mg of this will be acting also in downwards direction, so plus capital mg. So from here we will get that T dash cos theta is equal to mg by root 2 cos alpha, and since these are alternate interior angles, so alpha will be equal to 45 degrees. So I can write this as 1 by root 2. So from here I will get that this is T double dash cos theta is equal to mg by 2, and from in y direction I will get that so dividing these two I will get tan theta is equal to m by 2 plus m divided by m. So I will finally get that this is equal to m plus 2m by m. Two bodies of masses 2 kg and 3 kg are connected by a metal wire of cross section 0.04 mm square Breaking stress of metal wire is 2.5 gigapascal. The maximum force that can be applied to 3 kg block so that the wire does not break is. Okay, so the situation is something like this. This is 2 kg. There is wire and 3 kg. So the maximum tension that this block can sustain is 2.5 gigapascal. So maximum force that can be applied to the 3 kg block. So we know that the breaking stress is this much. So the breaking force will be given by .04 millimeter square, and if I convert it into meters, then this will be multiplied by gigapascal. This is because stress is force upon area. So force will be stress multiplied by area, which I have done. Sorry, this will be 9. So we will get, if I, so this is 10 raised to the power 6. So if I cancel, I will get 10 raised to the power 3, which will give us 100 Newton as the breaking stress. So the acceleration can be given as F by 5, because the total mass is 5 kg of the system. So force by mass is F by 5. And so if I write the force equation on 3 kg block, F minus T is equal to 3F by 5, which will give us tension as 2F by 5. Right, so this has maximum value 100. So this gives us force as 250 Newton. So the answer is option D. Moving on to question 13, we have a block of mass m is placed on an inclined plane with angle of inclination theta. Let n, Fl and F respectively represent the normal reaction, limiting force of friction and the net force down the inclined plane. Let mu be the coefficient of friction. The dependence of Newton, Fl and F on theta is indicated by plotting graphs as shown, and we have to identify which is 1, 2, 3. So imagine that this is theta, and theta is, we are continuously increasing it. So when the theta is small, then so the normal will vary with theta as mg cos theta, and the friction will vary as, it will be equal to mg sin theta till the time mg sin theta is less than the limiting friction, right? Because till the time mg sin theta becomes equal to the mu n, then friction should be equal to mg sin theta, because if friction is equal to mu n, then mu n will be greater than mg sin theta. So the block will start moving upwards, which is not possible. So the block will be at rest and F will be equal to mg sin theta. And after mg sin theta becomes more than mu n, then it will become mu n, which is mu mg cos theta, after mg sin theta is more than mu n. So the F, which is the downward force, it will be given by mg sin theta minus mg sin theta, which is equal to 0 till mg sin theta is less than mu n, which is mu mg cos theta. So till tan theta is less than mu. This is the angle of repose also, and downward force will become mg sin theta minus mu mg cos theta after tan theta is more than mu, right? And FL is not F. FL is the limiting friction, and limiting friction is fixed as mu mg cos theta. So let us plot n first. So n as a function of theta. So n is mg cos theta, right? So at 0 degrees cos theta is 1. So this will start with mg and it will become 0 at 90 degrees. Right, this is the plot of n, and limiting friction is mu mg cos theta, and mu is less than 1. So at 0 degrees it will be mu mg, which will be less than mg, and it will also become 0 at 90 degrees. And the force down the incline is 0 till some value, and after that it becomes mg sin theta minus mu mg cos theta, and at 90 degrees this will be 0 and this will be 1. So downward force will become mg at 90 degrees. Right, so this is F. So let us compare now. On comparing, we will get that option C is correct. This was a nice question. So let us move on to the 14th question, which says that a uniform rope of length L and mass M partially lies on a horizontal table and partly hangs from the edge of the table. If mu is the coefficient of friction between rope and the surface of the table, the maximum fraction of length that overhangs from the edge of the table without sliding down is. So assume that some part of the rope is hanging and other part is down, and total length is L. So if I assume this as A, this will be L minus A, and a tension will be acting and mg will be acting downwards, right? So the tension over here will be equal to mg, where m is the mass of this rope, right? So if the total mass is m, so of unit length it will be m by l, and of length l by l minus a it will be this much. So this will be equal to tension, right? Because mass of this is this much multiplied by g is equal to tension. I use unitary method. So now on this part, the same tension will be acting here and mu n will be acting here. So mu multiplied by m by l multiplied by a, which is the mass of this, multiplied by g, is equal to m by l multiplied by l minus a g, right? So mu will be equal to L minus A divided by A. So we need to find the maximum fraction of length that the rope overhangs. So we need to find A. So mu plus 1 A is equal to L. So A is equal to L by mu plus 1, and the overhanging length, which is L minus A, this will be equal to so this will be the answer, which is we need to find the fraction, right? So fraction will be L mu divided by mu plus 1 divided by L. So mu by mu plus 1, which is equal to the option B. So moving on to question 15, it says that a monkey holds a light rope that passes over a smooth pulley. A bunch of bananas of equal mass as that of the monkey is attached on the other side of the rope. The monkey starts climbing the rope to get to the bananas then. Okay, so the situation is like this. Assume that the monkey is here with mass m and the bananas are here. So the monkey will start climbing upwards, so there will be tension T and mg will be acting downwards. And if the acceleration of the monkey is assumed to be am upwards, then we cannot say that the acceleration of bananas will be equal to am in magnitude, because when we have two blocks attached, then we can write the constraint that if this is L1 and this is L2, then if m will move upwards with x1 distance and this will move downwards with x2 distance, then L1 plus L2 should be equal to L1 minus x1 plus L2 plus x2. So this gives us that x2 is equal to x1, and on double differentiating we get a2 is equal to a1. But this is not the case here. Because here what is happening, if this is the monkey and this is banana and this is L1 and this is L2, then the monkey will move upwards over here. Monkey will reach here, right? So it will move x1 distance upwards, and this will assume that it will move x2 downwards. Then we cannot say that L1 plus L2 is equal to some relation, right? Because this length is getting wasted. The monkey is moving upwards, so this is now the length which we have to consider. So no relation can be obtained because the monkey is not at the end point of the rope now. It has moved upwards to this point, and this is the new end point of the rope. So I am assuming this to be tension here and acceleration of banana in downwards direction. So if we add these two equations, then we will get so the banana and monkey both are moving upwards with acceleration am. And in relative frame, both will appear to be stationary to each other because the acceleration is equal. So if we take relative to any one frame, then the acceleration will get cancelled. So the monkey is moving upward, so banana will also move upward. Banana will not move downward. The distance between monkey and banana will decrease. No, because they are at rest to each other, so distance should remain constant. So A and D are correct. So let's see question 16 now. It says a particle of mass small m moves along a straight line under the action of a force small f, varying with time as f is equal to f naught bracket 1 minus t minus capital T by t whole square, where f naught and t are positive constants. Then speed of the particle is asked and many more things are asked. So this is a 6-marker question, so this is multiple choice. So first we can write this force as mass into acceleration, which is equal to mass multiplied by dv by dt is equal to f naught 1 minus t minus capital T by capital T whole square. So now rearranging, we will get m by f naught dv is equal to 1 minus t square plus capital T square minus 2t capital T by capital T square dt. So from here we will get it is given that if we assume that at time is equal to 0 the velocity was 0, then we will get at any time t the velocity is v, so mv by f naught is equal to t minus t cube by 3t square plus t minus 2t square by 2t. So from here we will get t minus t cube by 3t square minus t plus 2t square by capital 2t. 2 and 2 will get cancelled and this t and this t will get cancelled. So velocity is equal to f naught by m multiplied by minus t cube by 3t square plus t square by t. So after a time 2t, velocity we have to calculate. F naught by m minus 8 by t cube by 3t square plus 4t square by t. So from here we will get f naught by m 4 minus 8 by 3, which is equal to 4 by 3 t. So option A is correct. Now we have to find when will the particle start moving backwards. So if we find the time at which velocity will be 0, then the velocity will become 0 and then it will start becoming negative, right? So at turning point the velocity will be 0, so minus t cube by 3t square plus t square by t should be equal to 0, which will give us t cube by 3t square is equal to t square by t. So t is equal to 3t. So B option is also correct. Now acceleration between 0 and 2t is first positive and then decreases. First increases then decreases. So D is also correct because we found out that it will stop at 3t. Now let us find the acceleration. So acceleration we can find out by differentiating the velocity and we will get f naught by m minus t square by t plus 2t by capital T. So now we need to find when will the acceleration decrease and when will it will decrease. So we will find the derivative of acceleration. And when will this be equal to 0? So we will find out that it is 0 at t is equal to t, and d square a by dt square is this. So we will find the maxima at t is equal to capital T, right? So acceleration will be something like this. So we can see that acceleration is increasing first and then it is decreasing between 0 and 2t. So option C is also correct. So answer for question 16 is ABCD. So question 17 says a block is placed on a surface with vertical cross section given by equation y is equal to x square by 20. Coefficient of friction is half. Then the maximum height above the ground at which block can be placed without slipping. So the curved surface is like this. And assume that this is the maximum height at which the block can be placed. Right, so mg will be acting downwards and the friction will be acting tangent at this point, right? So we need to find this angle to take components of mg, right? So we know that dy by dx gives us the tan theta at any point. So dy by dx will be x by 10 and x we can replace using this formula as root 20y by 10, which will be equal to root y by root 5. Here y is the y max. So mg sine theta is equal to mu mg cos theta because the block is not slipping, and this is the triangle that we obtained. So this will be y plus 5. So from here we can substitute sine and cos. Mg y by y plus 5 is equal to half mg root 5 by y plus 5. So from here cancelling out we will get, if we square both sides, we will get y is equal to 1 by 4 multiplied by 5. So y is 5 by 4, right? So we will get the answer as B. This was a nice question. Instead of an inclined plane where the angle is constant, angle will be changing at every point and we need to find the slope to find the angle. So question 18 says a metal block is resting on a wooden surface. A horizontal force applied to the block is increasing uniformly. Which of the following curves correctly represents the velocity of the block? Okay, so assume that since the horizontal force applied is increasing uniformly, we can assume the force as a function of t with some constant. So from here we will get that the diagram is like this, and friction will be acting here. So the velocity will be, or rather I should say the acceleration will be 0 till the time, if this has mass as m, then mg will be acting downwards and n will be upwards. So limiting friction is mg. So till the time this kt is less than mg, we will have the acceleration as 0 because this force can balance this kt if this is less than mg, right? Sorry, this will be mu mg. So till the time kt is less than mu mg, then the friction can balance this kt. So till the time t is less than mu mg by k, the acceleration will be 0, and after that the acceleration will be kt minus mu mg. Okay, so from here we need to find the velocity. So the velocity will be constant till this time. And since it is at rest, so it will be 0. And after that, it will start becoming kt square by 2 minus mu mg t divided by m. Right? So this is the formula of a parabola. Since there is a t square term. So this is wrong. This is wrong because there is a straight line. This has first constant then parabola. So this is correct. Option C. And this is wrong because this is a straight line. So answer is option C. Now moving on to question 19, it says a person is sitting in a moving train and is facing the engine. He tosses up a coin which falls behind him. He concludes that the train is moving. So the person is facing the engine, right? So assume that the engine is here. And he tosses a coin which is falling behind him. So if the train is moving forward with increasing speed, then the velocity and acceleration will be in this direction. And when the coin is tossed, it will have velocity v, but acceleration is not transferred. So the distance traveled by the train in same time is more than the distance traveled by the coin, because the train also has acceleration, but coin only has velocity. So the distance traveled will be more for the train than the coin. So train will be at a greater x coordinate than the coin after which the coin falls. So option A is correct because the coin will fall behind him. And forward with decreasing speed, no, because the train will move less distance than the coin. So B is wrong. And let us see backward with some acceleration. So if the train is moving backwards with decreasing acceleration, that means that velocity will be in this direction and acceleration will be in this direction. I'm checking for option D. So if a person is facing the engine and the velocity is in this direction, so the coin will move with some distance here and the train will move in this direction, but it will move less, right? So the coin will move greater direction in the left side, right? So the coin will move below, coin will move behind the person. So option D is also correct and option C is wrong. This was a nice question, and if you have any doubt, you can ask me.